We live on a restless planet, a world of hurricanes that can level cities, of volcanoes that can blot out the sun, of earthquakes that can shatter the very ground beneath our feet. We look upon these forces with a sense of terror and of awe. We believe we know what a dangerous environment is, but this is a profound and comforting illusion. The most violent storms on Earth are but a gentle breeze in the context of the cosmos. The most cataclysmic eruption on our world is a mere flicker. Beyond our quiet solar system lies a gallery of monsters, a collection of worlds so extreme, so violent, and so fundamentally hostile to life that they make our planet's greatest furies look like a peaceful summer's day. Tonight, we journey to the most dangerous planets ever discovered. We will see worlds where the rain is made of molten iron, where the winds break the sound barrier, and where gravity is a weapon of mass destruction. Prepare to leave the safety of our earthly paradise behind. The universe is about to show us its true and terrifying face. Before we can begin our tour of the universe's most dangerous destinations, we must first understand how we find these hidden worlds in the first place. An exoplanet, a planet orbiting another star, is an object of almost impossible subtlety. It is a tiny, dark, and non-luminous speck, trillions of miles away, completely overwhelmed by the brilliant, ferocious glare of its parent star. Finding one of these worlds is one of the greatest technical challenges in the history of science. It is an act of cosmic detective work, a search for an invisible suspect, using only the faintest and most ghostly of clues. The first and most powerful of our detection methods is a technique of beautiful simplicity called the transit method. It is a hunt for a shadow. Our most advanced space telescopes, like the legendary Kepler and its successor, TSS, are designed to stare, unblinking, at vast fields of hundreds of thousands of stars. They measure the brightness of each star with a precision that is almost supernatural, and they wait, patiently, for a tiny, rhythmic, and almost imperceptible dip in a star's light. This tiny dimming is the shadow of a planet passing, or transiting, in front of its star from our point of view. Let's use an analogy. Imagine you are standing miles away from a colossal, brilliant searchlight, and you are tasked with detecting the presence of a single, tiny flea flying around its lamp. You could never hope to see the flea directly, but if that flea were to pass directly between you and the searchlight's beam for a fleeting moment, the light would dim by an almost immeasurable amount. The transit method is how we have learned to detect the cosmic fleas. By measuring how much the light dims, we can calculate the size of the planet. By measuring how often the dimming repeats, we can determine its year. Our second great tool is the radial velocity method, a technique that listens for a wobble. We think of a planet as orbiting its star, but the truth is more complex. The planet and the star both orbit their common center of mass. Because the star is so much more massive, it only moves in a tiny, almost imperceptible circle. The star wobbles. Imagine a powerful athlete, a hammer thrower, spinning a heavy metal ball around them. As they spin, their own body has to lean back and move in a small circle to counteract the force of the hammer. You might not be able to see the hammer itself in the blur of the spin, but by watching the wobble of the athlete, you can know with absolute certainty that the hammer is there, and you can even calculate how heavy it must be. We do the same with stars. We watch for their wobble by analyzing their light. As the star moves towards us in its tiny orbit, its light waves are compressed or blue shifted. As it moves away, its light waves are stretched or red shifted. This tiny rhythmic pulse in the starlight is the fingerprint of an unseen planet, and it allows us to measure its mass. These two methods have opened the floodgates, revealing over 5,000 confirmed exoplanets to date. But they have a powerful, built-in bias. They are best at finding the planets that are easiest to find. The giants, the monsters, the worlds that are so massive, they create a big wobble, or so close to their stars, they create a frequent and deep transit. This is why our early discoveries were dominated by a class of worlds called hot Jupiters. These are the very worlds that are often the most extreme, the most violent, and the most dangerous. Our planet hunting methods have not just given us a census of the cosmos, they have given us a catalog of danger zones, a guide to the most treacherous and hostile shores of the cosmic ocean. And our first destination is a world where the weather itself is forged from metal. Our first journey into the gallery of cosmic dangers takes us 640 light-years from Earth, to a world that has captured the horrified imagination of scientists and the public alike. On Earth, we have experienced rain of all kinds. We have sheltered from gentle drizzles and from torrential downpours. But what if the clouds were not made of water vapor, but of metallic vapor? What if the rain itself was not water, but molten, liquid iron? Welcome to the planet WASP-76b. It is a world that is a living, breathing, planetary-scale blast furnace. WASP-76b is a monstrous gas giant, a so-called ultra-hot Jupiter, almost twice the size of our own Jupiter. But it is locked in an orbit of suicidal proximity to its parent star, a star that is hotter and larger than our own sun. Its year, the time it takes to make one full circuit, is a mere 1.8 Earth days. This nearness has created an environment of almost unimaginable violence and heat. The planet is tidally locked to its star, which means that one hemisphere is in a state of perpetual searing day, while the other is turned away, in a state of eternal, but still incredibly hot, night. Let's first visit the day side. The star, from this vantage point, would be a terrifying colossal orb filling a huge portion of the sky. The temperature on this sun-blasted side of the planet is a staggering 4,350 degrees Fahrenheit, or 2,400 degrees Celsius. This is a temperature so extreme that it is not just hot enough to melt metal, it is hot enough to vaporize it. The surface of WASP-76b is not a solid or a liquid. It is a churning gaseous inferno, and in this inferno, the iron that exists on the planet is not a solid, it is a gas. The day side of the planet has an atmosphere that is rich with iron vapor. Now, just as on Earth, this extreme temperature difference between the day side and the night side drives winds of almost unbelievable power. Ferocious, superheated winds, traveling at thousands of miles per hour, are constantly blowing from the hot day side to the cooler night side. And these winds carry the atmosphere of iron vapor with them. The night side, while in darkness, is not cold. The temperature is still a blistering 2,700 degrees Fahrenheit. But this is just cool enough for the iron vapor to do something extraordinary. It condenses, just as water vapor in Earth's atmosphere condenses to form clouds of liquid water droplets. The iron vapor on WASP-76 bed condenses to form clouds of molten liquid iron. And from these clouds it rains. This is not a metaphor. It is a literal, physical reality. The night side of WASP-76b experiences a constant, global, and torrential downpour of liquid, molten iron. Imagine a blacksmith's forge, the size of a world. The day side is the furnace, where the iron is melted and turned into vapor. The winds are the bellows, carrying that vapor across the workshop. And the night side is the anvil, where the molten metal condenses and falls back down in a shower of glowing liquid terror. This is the weather on WASP-76b, a cycle of vaporizing metal, of ferocious winds, and of molten iron rain. Any spacecraft attempting to enter this atmosphere would be simultaneously vaporized by the heat and sandblasted into oblivion by a storm of liquid metal. It is one of the most hostile and dangerous environments we have ever discovered. But the universe is a place of almost infinite imagination, and it has created worlds that are even more geologically violent. From the atmospheric nightmare of iron rain, our journey now takes us to a world where the danger is not in the sky, but in the very ground beneath our feet. We think of a planet as a place of solid, stable land, a place of mountains, of continents, of rock. But we are now traveling to a world that has been melted to its very core, a planet where the surface is not solid at all, but is a vast, churning global ocean of molten lava. This is the planet Core OT7b, and it is a true vision of a geological hell. Located nearly 500 light-years away, Core 7b was one of the very first rocky super-Earth exoplanets ever discovered. It is about 1.5 times the size of our own planet, and about 5 times its mass. It is a world made of the same basic rocky ingredients as our own. But that is where any similarity to our gentle home ends. For this planet is in an orbit so close, so tight, that it almost defies belief. Its year, the time it takes to complete one full orbit around its sun-like star, is a mere 20 hours. It is spinning around its star like a stone in a sling, a world on the very brink of destruction. This extreme proximity has, of course, tidally locked the planet. One side forever faces its star, and one side forever faces the cold of space. And the conditions on the star-facing side are a true apocalypse. The temperature is estimated to be over 4,000 degrees Fahrenheit, or 2,200 degrees Celsius. This is a temperature so high that it is far above the melting point of rock itself. The entire star-facing hemisphere of Coret 7b is not solid. It is a single vast and terrifyingly deep ocean of molten magma. Let's use an analogy. Imagine taking our own planet, Earth, with all its continents and oceans, and placing it in a celestial blast furnace. First, the water oceans would boil away in an instant. Then the continents themselves, the great land masses of granite and basalt, would begin to glow red, then white, and then they would melt, slumping and collapsing into a single incandescent, planet-wide sea of liquid rock. This is the permanent stable state of the day side of Coret 7b. But the danger does not stop at the surface. Just as on the Iron Rain planet, the heat is so extreme that the molten rock itself begins to evaporate. The lava ocean boils. This creates a thin, searingly hot atmosphere of vaporized rock. The air itself is made of gaseous minerals, creating a sky of silicate vapor. And just as on other tidally locked worlds, this creates a weather cycle of almost unimaginable violence. Supersonic winds carry this atmosphere of rock vapor over to the cooler, dark side of the planet. Here, the temperature is still incredibly hot, but it is cool enough for the rock vapor to condense. It forms clouds of mineral dust, which then precipitates and falls back to the ground. This is a rain of solid rock, a constant shower of pebbles and sand, falling out of a vaporized stone sky. The geology of this world is a nightmare. The surface is a roiling, bubbling sea of magma, constantly stirred by the supersonic winds and the rain of rock. There would be no solid ground to stand on, only a thin, fragile crust of cooling rock at the terminator, the twilight zone between the hot and cold sides. And this crust would be constantly cracking, foundering, and being consumed by the lava ocean beneath. It is a world where the very idea of a solid surface is a temporary and dangerous illusion. It is a planet that has been fundamentally and permanently melted. We have witnessed the danger of fire. We have seen worlds melted by their stars. But there is another kind of danger in the cosmos, a danger born not of proximity, but of a profound and terrifying loneliness. We now journey to a world that is not a prisoner of its star, but an exile, a planet that has been cast out to the farthest, darkest, and coldest frontiers of its solar system, a world living in a state of almost complete abandonment. This is the planet HD 106906b, and it is the loneliest known world in the entire universe. HD 106906b is a true monster. It is a colossal gas giant, 11 times more massive than our own Jupiter. It orbits a pair of bright, young, sun-like stars, a beautiful binary system located about 336 light-years from Earth. But it is the orbit of this planet that is so shocking, so bizarre, and so dangerous. It orbits its two parent stars at a distance of over 68 billion miles, or 110 billion kilometers. This is a distance that is almost impossible to comprehend. Let's try to put it into our own solar system's context. The last planet, Neptune, orbits our Sun at a distance of about 2.8 billion miles. HD 106906b is over 20 times farther away from its stars than Neptune is from our Sun. It is a distance of over 730 astronomical units. A beam of light from its parent stars would take over 4 days to reach it. From the upper atmosphere of this giant, lonely world, its two parent stars would appear as nothing more than a single brilliant star-like point of light, far brighter than any other star in its sky, but still just a point. The warmth and the light it receives from them would be almost negligible. The temperature in its upper atmosphere is a profound cryogenic cold, hundreds of degrees below zero. It is a world that is, for all practical purposes, living in the darkness and the cold of interstellar space, barely connected to the star system it calls home. The danger of this world is the danger of profound and absolute isolation. Let's use an analogy. Imagine a great, warm, and brightly lit house, which is the central star system. This planet is a tiny, unheated shed at the very back of a property that is 20 miles long. It is technically part of the same system, but it receives almost none of the light, none of the warmth, and none of the benefits of being near the house. It is a forgotten and abandoned outpost. The very existence of this planet is a deep and profound mystery. A gas giant of this immense size should not be able to form this far away from its parent stars. The primordial disk of gas and dust from which planets are born would have been far too thin and too sparse out here to build such a monster. So how did it get there? The most likely scenario is that this planet was born much closer to its twin suns in the chaotic, crowded inner region of the system. And then, a violent gravitational interaction, a close encounter with another massive planet, or the complex tug-of-war between its two parent stars, violently ejected it, flinging it out on this vast, lonely, and eccentric orbit. This planet is a refugee, chained to survivor of a planetary war, and its journey may not be over. Its orbit is so vast and so weakly bound to its stars that it is highly susceptible to the gravitational nudges of other passing stars. It is living on the very brink of escape. The slightest gravitational disturbance could be enough to sever its last tenuous connection to its home and send it wandering off into the void to become a true rogue planet. The danger of this world is a quiet and lonely one. It is the danger of a world that has been cast out, a testament to the fact that even the most massive and powerful of planets can be victims of the violent and chaotic game of celestial mechanics. We have seen worlds of fire and of ice, of storm and of exile. The dangers have been external, forces imposed upon a world by its star or its history. But we now journey to a world where the danger comes from within, a world where the most terrifying force is the planet itself. A planet where the gravity is so extreme, so relentless, and so unforgiving that it is a weapon of mass destruction. We are traveling to a world where you would be flattened into a paste the moment you arrived. This is a class of worlds known as super-Earths. They are rocky planets like our own, but significantly more massive. A prime example is the planet Kepler-10b, one of the first and most famous of these worlds to be discovered. Located about 560 light-years away, Kepler-10b is only about 1.5 times the size of Earth, but it is over 4.5 times as massive. This means its density is incredibly high, denser than a solid ball of iron. It is a true heavyweight champion of the rocky worlds. This immense mass, packed into a relatively small volume, creates a surface gravity that is a true monster. The gravitational pull on the surface of Kepler-10b is estimated to be over 2.5 times that of Earth. What would it be like to stand on the surface of such a world? It would be a short and brutal experience. Imagine a person who weighs 180 pounds on Earth. The moment they were magically transported to the surface of Kepler-10b, their weight would instantly increase to over 450 pounds. The sheer crushing force of their own weight would be a catastrophic event for their body. Let's use an analogy. Experiencing the gravity of Kepler-10b would be like trying to stand up and walk around with another full-grown adult human being permanently sitting on your shoulders. Every single movement would be a Herculean effort. Your legs would likely buckle and shatter under the strain. Your spine would be compressed. Your heart, which is a muscle designed to pump blood against the gentle pull of one Earth gravity, would be completely unable to overcome this new crushing force. It would fail to pump blood to your brain, and you would lose consciousness in a matter of seconds. You would not just be heavy, you would be dying. And Kepler-10b is a relatively modest example. We have found other, even more massive rocky worlds, mega-Earths, with surface gravities that could be 5 or even 10 times that of our own. On such a world, a 180-pound person would weigh nearly a ton. You would not just be immobilized, you would be physically flattened. Your ribcage would collapse, your organs would rupture, and your body would be reduced to a thin biological stain on the surface of a world that is actively trying to crush you out of existence. The danger of a high-gravity world is a quiet, persistent, and absolute one. It is a world that is fundamentally and permanently hostile to the very structure of life as we know it. All of the complex, delicate machinery of biology on Earth has been fine-tuned over billions of years to operate under the gentle, forgiving pressure of 1G. On a super-Earth, this machinery would instantly and catastrophically fail. These worlds are a humbling reminder that even the most fundamental forces of nature can be a weapon. Gravity, which on our world is the gentle force that keeps us anchored to the ground, can, on other worlds, be a monstrous and unyielding tyrant, a force that forbids the very possibility of movement, of complexity, and of life. We have journeyed to worlds of incredible heat before. We have seen lava oceans and atmospheres of vaporized rock, but we have saved the true undisputed king of the cosmic infernos for now. We are about to journey to a world so hot that it redefines the very boundary between a planet and a star, a world that is being so savagely and so relentlessly blasted by its sun that its own atmosphere is being boiled away into space in a great glowing tail. This is the planet KLT9, and it is the hottest planet ever discovered. Located 670 light-years from Earth, KELT 9b is a colossal gas giant, nearly twice the size of Jupiter and almost 3 times its mass. It orbits a monstrous, brilliant blue A-type star, a star that is more than twice as hot as our own Sun. And it orbits this celestial furnace at a distance that is almost beyond belief. It is so close that its year lasts for less than 1.5 Earth days. This combination of a super hot star and a suicidal orbit has created a planet that is hotter than almost anything else in the universe. The temperature on the day side of KELT 9b is a staggering 7,800 degrees Fahrenheit, or 4,300 degrees Celsius. Let's pause to put this number into its proper terrifying context. This is a temperature that is hotter than the surface of most stars in our galaxy. The common dim red dwarf stars that make up the vast majority of the stellar population have surface temperatures of only about 5,000 degrees Fahrenheit. This means that KELT 9b is a planet that is literally hotter than 80% of the stars in the universe. It is a world that has been heated to the point where it has become a star-like object in its own right. On the day side of this planet, the conditions are apocalyptic. The heat is so intense that the molecules in its atmosphere are being torn apart. Hydrogen molecules are ripped into individual atoms. The atmosphere is not made of gas in the traditional sense. It is a seething, incandescent plasma of dissociated atoms. Even the heavy metal elements, like iron and titanium, which we have seen rain on other worlds, exist here as a permanent glowing gas. Let's use an analogy. KELT 9b is like a lump of cosmic iron that has been placed directly into the heart of a celestial blast furnace. It has been heated so intensely that it is no longer just red hot or white hot. It has been heated to the point where it is glowing with a brilliant blue-white light of its own. It is a planet that is shining like a star. And this process is one of slow, systematic, and total annihilation. The planet is being destroyed. The intense ultraviolet radiation from its parent star is so powerful that it is blasting the planet's atmosphere away into space. This is a process called photoevaporation. KELT 9b is trailing a colossal comet-like tail of its own superheated vaporized atmosphere. We are witnessing a world that is being actively boiled alive. The rate of this evaporation is titanic. The planet is losing mass at a rate of over 100 trillion tons per second. It is a dying world, a gas giant that is being slowly and systematically unmade by the furious, unrelenting light of its own sun. Its KELT 9b is the ultimate dangerous planet. It is a world that is caught in a state between what it is and what it is becoming. It is a planet that is being heated so violently that it has begun to behave like a star. It is a testament to the fact that in the universe, there is no fury more destructive, no danger more absolute than being too close to the fire of a truly massive and powerful star. It is a world that is being erased from the cosmos, one superheated atom at a time. We have seen planets tortured and destroyed by their living, breathing stars. The dangers have been those of fire and of fury, but our next journey takes us to a place that is, in many ways, even more unsettling. A place where the danger is more ghostly, more radioactive, and more profound. We are now traveling to a solar system where the central star is not alive. It is a corpse. An undead, spinning, stellar zombie that is constantly bathing its orbiting worlds in a torrent of lethal radiation. We are visiting the pulsar planets. A pulsar is one of the most exotic and violent objects in the known universe. It is a type of neutron star, the super-dense, crushed, city-sized remnant of a massive star that has died in a supernova explosion. It is an object so dense that a single teaspoon of its substance would weigh 1 billion tons, and it is often spinning with the speed of a kitchen blender, hundreds of times per second. As it spins, it sweeps a lighthouse-like beam of intense focused radiation across the cosmos. This beam is a torrent of radio waves, X-rays, and gamma rays. This is not a life-giving sun. This is a cosmic death ray. And in 1992, in one of the most shocking and unexpected discoveries in the history of astronomy, we found planets orbiting one of these stellar corpses. The system is named PSRB 1257+12. Located 2,300 light-years away. This pulsar is home to at least 3 rocky terrestrial planets, 2 of them with masses similar to our own Earth. The very existence of these worlds is a profound and terrifying mystery. The supernova that created the pulsar should have been an event of almost unimaginable violence. The explosion should have vaporized any nearby planets, or at the very least, blasted them out of their orbits into interstellar space. How did these worlds survive? The horrifying answer is that they probably didn't. These are not survivor planets. They are second-generation planets. They are zombie worlds, formed from the debris of the dead star itself. Let's create an analogy. Imagine a great, beautiful tree, with several apples growing on its branches. A bolt of lightning strikes the tree, and it explodes into a million pieces. The original apples are destroyed, but now, from the smoldering dead stump of the tree, a strange, new, and unnatural kind of fruit begins to grow. This is the pulsar planet system. The original planets were destroyed in the supernova, but a disk of fallback material, the dead matter from the explosion, formed around the newly created neutron star. And from this disk of death, a new family of planets was born. These worlds are not made of the primordial, hydrogen-rich gas of a normal solar system. They are made of the exotic, heavy elements forged in the heart of the dead star. They are worlds made of pure nuclear ash, and their existence is a perpetual nightmare. Imagine standing on the surface of one of these worlds. There is no gentle, warming sunlight. Instead, your sky is dominated by the terrifying strobing pulse of the central pulsar, flashing its beam of radiation across your world hundreds of times per second. The planet would be bathed in a constant lethal flood of X-rays and gamma rays. The pulsar wind, a torrent of high-energy particles traveling at nearly the speed of light, would be slamming into the planet's magnetic field, creating the most intense and violent auroras imaginable. A permanent, ghostly, and deadly light show in the sky. The surface of the planet would be utterly sterile, scoured clean of any possibility of life. It is a world born from death, orbiting a corpse, and bathed in a constant torrent of lethal radiation. It is the ultimate cosmic graveyard. It is a true zombie planet, a testament to the fact that even in the aftermath of the universe's most violent explosions, planets can be born. But the worlds that are born in such a place are not worlds of life. They are worlds of unending, radioactive horror. Our journey has taken us hundreds of light years across the galaxy, to the most violent and extreme exoplanets we have ever discovered. But for our next destination, we must return home. For one of the most dangerous and bizarre worlds we know of is not in a distant star system, but right here in our own solar system. It is a world we have known of for centuries, but whose true chaotic and dangerous nature we are only just beginning to understand. We are traveling to the seventh planet from our sun. We are visiting the ice giant, Uranus. From a distance, Uranus appears as a serene, featureless, and almost disappointingly calm blue-green ball. It lacks the vibrant, stormy bands of Jupiter or the magnificent rings of Saturn. It is a world of quiet, cold beauty. But this serene appearance is a mask. It hides a world of seasons so extreme, so long, and so violent, that they would make the worst ice ages and heat waves on Earth look like a gentle spring day. The danger of Uranus is a danger of profound and catastrophic instability. The source of this chaos is the planet's most famous and most mysterious feature, its extreme axial tilt. Let us use an analogy. Imagine the planets of our solar system are all spinning tops, all spinning on a vast, flat table, which is the plane of the solar system. Most of the planets, like Earth, are spinning more or less upright, with only a small, gentle tilt. This is what gives us our regular, predictable seasons. Uranus is a spinning top that has been knocked completely over. It is tilted on its side by a staggering 98 degrees. It is effectively rolling along its orbit, a colossal blue-green ball spinning on its side. What this means is that for its long 84-year orbit around the Sun, its seasons are unlike anything else in the solar system. For a quarter of its year, a full 21 Earth years, one of its poles is pointed directly at the Sun. That pole experiences 2 continuous decades of sunlight, a single, unending summer's day. At the same time, the other pole is pointed away from the Sun, plunged into a 21-year-long winter of absolute, unending darkness and cryogenic cold. Then, as the planet continues in its orbit, the situation slowly reverses. The equator faces the Sun, bringing a bizarre and chaotic spring and autumn, where the entire planet experiences a rapid 12-hour cycle of day and night. And then, the other pole faces the Sun, beginning its own 21-year-long summer. while the first pole is plunged into its 2 decades of darkness. This is a recipe for the most violent and extreme weather in the solar system. Imagine a hemisphere of a planet that has been in a deep freeze, hundreds of degrees below zero for 2 decades. And then the sun rises, and it does not set again for another 2 decades. The slow but relentless influx of solar energy into the frozen atmosphere would trigger storms of almost unimaginable scale and power. For a long time, we thought Uranus was a quiet world. When Voyager 2 flew past in 1986, it was during the middle of the planet's southern summer, and the images it sent back were of a calm, almost featureless blue-green haze. But as our telescopes have improved, and as the seasons on Uranus have changed, we have begun to see its true violent nature. In the years since its equinox in 2007, as the sun's light has begun to shine on the previously dark hemisphere, we have seen the planet erupt. We have witnessed the birth of colossal continent-sized storms with brilliant white clouds of methane ice and dark, swirling vortices the size of oceans. The winds on Uranus are ferocious, reaching speeds of over 560 miles per hour. And these winds are not just confined to the equator. The extreme seasonal changes can trigger planet-wide atmospheric disturbances, creating a chaotic and unpredictable global weather system. The danger of Uranus is the danger of a world with a broken thermostat. Its extreme tilt means it can never find a stable equilibrium. It is a planet that is constantly being thrown from one extreme to another, from 2 decades of absolute frozen night to 2 decades of relentless, storm-generating sun. It is a world of chaotic, violent, and unending seasonal whiplash. And the cause of this great tilt remains one of the greatest mysteries of our own solar system. The leading theory is that in its youth, the young Uranus was struck by another, Earth-sized protoplanet in a cataclysmic, world-shattering impact that literally knocked it on its side. The serene, blue-green giant we see today is a beautiful, placid-looking victim of a past trauma of almost unimaginable violence. We have seen worlds that are dangerous by their very nature, worlds of fire, of ice, of chaotic seasons. But we now journey to a world where the danger is of a different and far more sinister kind. We are about to visit a world that is not just in a dangerous place, it is a victim. It is a planet that is being actively, systematically, and violently murdered by its own parent star. We are witnessing a cosmic crime in progress, a world being eaten alive. This is the tragic and terrifying fate of the planet WASP-12b. Located 750 light-years away, WASP-12b is a hot Jupiter, a gas giant about 1.5 times the mass of our own Jupiter. But it is in an orbit of such suicidal proximity to its star that it has become the ultimate cautionary tale. It orbits its sun-like star at a distance of only 2.1 million miles, a tiny fraction of the distance between Mercury and our Sun. Its year is a frantic, searing 26 hours long. This closeness has created 2 horrifying conditions that are leading to the planet's demise. The first is the heat. The day side of WASP-12b is tidally locked to face its star, and it is cooked to a temperature of over 4,600 degrees Fahrenheit, or 2,500 degrees Celsius. This is one of the hottest exoplanets ever discovered, a world so hot it is on the verge of being torn apart by its own thermal energy. But the true weapon that is killing this world is the tidal force. We have discussed tidal forces before, the stretching effect caused by a difference in gravitational pull. For WASP-12b, these tidal forces are not just a gentle stretch, they are a planetary executioner. The star's gravity is pulling on the near side of the planet with a force that is titanically, unimaginably stronger than the pull on its far side. This differential pull is so extreme that the planet has been distorted. It is no longer a sphere. It has been stretched into the shape of an egg or a rugby ball, its pointed end aimed directly at the star that is destroying it. Let's use an analogy. Imagine a malevolent, giant hand the size of a star has reached out and grabbed a rubber ball the size of a planet. The hand is squeezing the ball, deforming it, and its gravitational fingers are digging into the ball's very substance, peeling its layers away. This is the reality of WASP-12b. The planet is being actively torn apart. The star's gravity is so powerful that it is overcoming the planet's own gravity. It is physically lifting the atmosphere off the planet and pulling it away. WASP-12 is bleeding its very substance into space. Astronomers, using the Hubble Space Telescope, have observed this process directly. They have seen a colossal shroud of gas surrounding the planet, a tail of its own atmosphere that is being siphoned away by the star. This stolen material does not fall directly into the star. Instead, it is being pulled into a vast, swirling, incandescent accretion disk around the star. The planet is feeding its own executioner. It is a cosmic vampire, slowly and systematically draining the lifeblood from its planetary victim. And the rate of this consumption is astonishing. The star is devouring its planet at a rate of nearly 200 trillion tons per second. WASP-12b is a dying world. It is losing its battle against its own sun. Based on the rate of mass loss, astronomers have calculated its remaining lifespan. It has, at most, about 10 million years left before it is completely and utterly consumed. 10 million years may seem like a long time to us, but on a cosmic timescale, it is a fleeting instant. We are not just looking at a planet, we are looking at a murder in progress. We are witnessing the final, agonizing moments of a world being erased from the universe. The danger of this world is the danger of being a victim. It is a testament to the fact that even a mighty gas giant, a planet with 400 times the mass of the Earth, can be destroyed by the relentless gravitational hunger of its parent star. It is a world that is a living, breathing, and dying example of the most dangerous place a planet can be too close to home. From the horror of a world being eaten alive, we now journey to a world where the danger is more subtle. A danger born not of destruction, but of an almost obscene level of wealth. A world where the most precious materials on Earth are as common as sand. We journey 41 light-years away to the constellation of Cancer, to a super-Earth that is one of the most exotic and bizarre worlds ever discovered. This is the planet 55 Cantrid, the Diamond Planet. At first glance, this world seems almost Earth-like. It is a rocky planet, about twice the size of Earth and 8 times its mass, but it orbits its parent star, a star very similar to our Sun, at an incredibly close distance, about 70 times closer than Earth. Its year lasts only 18 hours. Because of this proximity, it is scorchingly hot, with a surface temperature of over 4,000 degrees Fahrenheit, or 2,200 degrees Celsius. It is a world of fire, like others we have seen. But the true strangeness of 55 Concurve lies not in its temperature but in its chemistry. Our own solar system, and our planet, is relatively carbon poor. We are a system rich in oxygen and silicon, which is why our world is made of silicate rocks. But the 55 Concurve system is different. Observations of its star show that it is incredibly rich in carbon. And if the star is rich in carbon, then the planets that formed from the same primordial disk must be as well. This is the key to understanding this world. On a planet that formed in such a carbon-rich environment, the fundamental geology is completely different. The planet would not be made of granite and basalt, it would be made of carbon compounds. And under the immense pressures and temperatures in the planet's interior, what form does carbon take? It takes the form of diamond. Let us use an analogy. Imagine a planet where water is the most common mineral. The crust would be made of ice. The mountains would be glaciers. And deep inside, the pressure would create exotic high-pressure forms of ice. Now replace the water with carbon. The crust would be made of graphite and tar. The mountains might be spikes of pure carbon crystal. And deep inside, the immense pressure, thousands of times greater than the pressure that forms diamonds on Earth, would have crushed a significant portion of the planet's mass into a single planet-sized diamond. The interior of 55 Cantri is likely a colossal, solid diamond core. A layer of this diamond, thousands of miles thick, is likely surrounded by a strange, gooey ocean of liquid carbon, a sea of tar and carbides. And the atmosphere would be a thick, toxic smog of carbon monoxide and hydrogen cyanide. It is a world built not from the familiar geology of Earth, but from the alien chemistry of carbon. The danger of this world is a danger of twisted value. Imagine standing on its surface. The ground beneath your feet, the mountains in the distance, the very core of the world. It is all made of a material that on Earth is a symbol of rarity, beauty, and wealth. On this world, diamond is just dirt. It is as common and as worthless as gravel. A mountain range made of solid, flawless diamond would be a common and unremarkable feature of the landscape. The surface would be a dark, glittering nightmare, a black, graphitic crust, perhaps covered in pools of bubbling black tar, all under a searing, poisonous sky. And the pressure would be crushing. The heat would be vaporizing. but the sheer mind-bending exoticism of its composition is what makes it a true cosmic danger. It is a world that takes our human concept of value and shatters it, reminding us that in the grand cosmic laboratory, even the most precious jewels on Earth can be the building blocks of a planetary hell. It is a dangerous and profound reminder that the universe does not care about our sense of worth. We have seen worlds with one sun. We have even imagined the chaotic beauty of a world with two suns. But we now journey to a world that takes this to a new and even more unstable extreme. We are traveling 340 light-years away to the constellation of Centaurus, to a world that is locked in a gravitational dance with not one, not two, but three separate stars. This is the planet HD 131399 Ab, and it is a world of unending, chaotic, and unpredictable daylight. The planet itself is a true monster. It is a young super Jupiter, about 4 times the mass of our own Jupiter. But it is its home system that is a masterpiece of gravitational complexity. The planet orbits the brightest of the 3 stars, a massive, brilliant A-type star in a vast 850-year orbit. But this star is not alone. Further out, the other 2 stars, a sun-like G-type star and a cooler K-type dwarf, are locked in a close binary embrace, orbiting each other like a pair of celestial dancers. And this entire binary pair is in turn orbiting the main star and its planet. The view from the upper atmosphere of this world would be a thing of surreal and disorienting beauty. For much of its long year, all 3 suns would be visible in its sky at once, a brilliant trio of different sizes and colors, creating a world of triple sunrises, triple sunsets, and a complex, ever-shifting pattern of 3 different shadows. For about a quarter of its orbit, a full 140 Earth years, there would be a season of constant, unending daylight, as the 3 stars would be in the sky at all times. But this beautiful tri-sun sky is the backdrop for a profound and dangerous instability. Let's use an analogy. Imagine trying to navigate a small boat in a bay that has 3 separate, powerful, and constantly moving whirlpools. The gravitational environment of this planet is just as chaotic. The constant shifting and complex tug-of-war between its 3 parent stars makes its own orbit a thing of beautiful but terrifying uncertainty. The planet is currently in a stable, though vast, orbit, but it is on the very edge of stability. The slightest nudge, the slightest perturbation from a passing star could be enough to disrupt this delicate gravitational balancing act. And if that were to happen, the consequences would be catastrophic. The planet would be thrown into a chaotic, unpredictable orbit, like a pinball in a cosmic pinball machine. It could be sent on a collision course with its primary star. It could be flung into the path of its binary star companions. Or, most likely, it would be ejected from the system entirely, sent on a lonely journey into the void to become a rogue planet. The danger of HD 131399 AB is the danger of living on a knife's edge. It is a world that is a survivor, a testament to the fact that planets can and do form in these incredibly complex and chaotic multiple star systems. But its survival is not guaranteed. It is a world that lives under the constant threat of gravitational annihilation. A world whose beautiful triple sun sky is also the source of its potential and ultimate doom. It is a profound reminder that in the universe, the more complex a system is, the more ways there are for it to go catastrophically wrong. We have reached the end of our tour of the universe's most dangerous worlds. We have journeyed through a cosmic gallery of horrors, from the iron rains of WASP 76b, to the lava oceans of Korot 7b, to the crushing gravity of super-Earths, and the chaotic skies of a triple sun system. We have witnessed a universe that is, at almost every turn, fundamentally and creatively hostile to the conditions we would call safe. And this grand tour of danger forces us to ask a final, and perhaps most important, question. Why not here? Why is our own planet, Earth, a gentle, stable, and life-giving paradise, in a universe that seems to be so full of monsters? The answer is that we are the beneficiaries of a series of cosmic accidents, a long and improbable chain of good luck that has made our existence possible. Our own solar system, which we often think of as a normal and average place, is in fact a haven of almost unbelievable calm and stability. First, there is our star. The Sun is a G-type yellow dwarf, a type of star that is remarkably stable and long-lived. It is not a violent, flaring red dwarf like Proxima Centauri. It is not a searingly hot, short-lived blue giant, like the star that is boiling Kelt 9b. Our Sun is a calm, middle-aged, and predictable star, and it has provided our planet with a steady, reliable stream of energy for over 4.5 billion years. The long, uninterrupted runway that complex life needed to evolve. Second, there is our orbit. The Earth travels on a nearly perfect circular orbit in the dead center of our Sun's habitable zone. We are not on a wild, eccentric, and season-shattering orbit like HD 80606b. Our gentle 23-degree axial tilt gives us predictable and mild seasons, not the chaotic 21-year-long winters and summers of a world like Uranus. Third, there is our planetary bodyguard. In our outer solar system, we have the colossal gas giant, Jupiter. Its immense gravity acts as our cosmic bouncer, a gravitational shield that has absorbed or ejected countless comets and asteroids that would have otherwise been on a collision course with the Earth, preventing a constant rain of extinction-level impacts. Fourth, there is our freakishly large moon, born from a cataclysmic impact in our planet's youth. Our moon is enormous in comparison to its parent planet, and its presence is absolutely crucial. Its large gravity stabilizes the Earth's axial tilt, preventing wild, catastrophic swings in our climate that would make the evolution of complex life impossible. Let's use a final analogy. Imagine the universe is a great cosmic lottery. To get a planet like Earth, you need to win not just once, but a dozen times in a row. You need to win the right star lottery, the right orbit lottery, the right bodyguard lottery, and the right moon lottery. The planets we have visited on our tour are the lottery losers. They are the worlds that got one or two things right, but failed spectacularly on the others. They are the cautionary tales, the cosmic what-ifs. The danger of the universe is the norm. The safety of Earth is the miracle. The more we explore the cosmos, the more we discover the countless, creative, and terrifying ways that a planet can be a dangerous place. The more we must come to the profound and humbling conclusion that our own world is not just a pleasant place to live. It is a sanctuary, a precious and perhaps an impossibly rare exception to the universe's harsh and unforgiving rules. And it is our only home. Our journey is at an end. We began with a tour of the familiar dangers of our own world, and we have returned with a new and profound appreciation for its gentleness. We have walked through a cosmic house of horrors, a universe filled with worlds that are more terrifying than our worst nightmares. We have stood under a rain of molten iron. We have sailed on an ocean of lava. We have felt the crushing weight of a tyrant gravity, and we have witnessed the slow, agonizing death of a planet being eaten alive by its own sun. This journey has been more than just a catalog of cosmic dangers. It has been a lesson in perspective. It has been a mirror held up to our own world that has shown us how truly special, how truly rare, and how truly fragile our own existence is. The universe is not designed to be safe. It is not designed to be comfortable. The laws of physics, playing out over the vast and impersonal canvas of the cosmos, are far more likely to produce a molten, irradiated, or frozen hellscape than they are to produce a gentle, life-giving paradise like the Earth. We are the children of a cosmic miracle, the survivors of an almost impossible chain of fortunate accidents, the inhabitants of a quiet, stable, and protected sanctuary in a universe that is a minefield of chaos and violence. When we look up at the night sky, we should no longer see it as a serene and peaceful expanse. We should see it for what it is, a gallery of monsters, a collection of dangers, and among all those distant, hostile points of light, we should see our own world for what it truly is, a precious and perhaps unique exception. The greatest lesson of the most dangerous planets in the universe is a simple one. There is no place like home, and it is our most sacred duty to protect it.